So here's a question from a previous diploma exam. It says an electrolytic cell is used to produce molten aluminum from molten aluminum oxide. If a current of 5 times 10 to the 4 amps, that's a nice big current, that's what you would use in a industrial process, were applied to the electrolytic cell for 5 hours, then the predicted mass of aluminum produced would be. So we're trying to find the mass of aluminum, and we're given amps and time. So really what we're given is electrons. When you're talking about electricity, that's electrons, right? So this is a stoichiometry question. So what are the steps of stoichiometry? So the first step is always balanced equation. Now I have a balanced equation in the question, but it doesn't have any electrons in it. So that balanced equation isn't going to do it. I need a balanced equation that has electrons in it and also has aluminum in it. So what I really need is my aluminum half reaction. I need that my aluminum ions are combining with 3 electrons to make solid aluminum. There's my balanced equation that actually has aluminum and electrons in it, which is what I'm dealing with. The next step is to give your moles of given. So what are we given? We're given the electrons. So we need to figure out the moles of electrons. Well, how do we do that? Faraday's law. So Faraday's law is we're going to take the current times the time and divide it by the constant. But I want to show you how to do this one by unit analysis. So I'm going to do the same thing, but we're going to do it with units. So here I've found my moles of electrons. I took my time, changed it to seconds because it has to be seconds. I times it by my current, and I divided it by the constant. And as you see, the units cancel out. My hours cancel out, my seconds cancel out, then my coulombs cancel out. And what am I left with? I'm left with moles of electrons, which is what I want. That's my moles of given. So my next step is my mole ratio. So it's always what I want on top, what I'm given on the bottom. Well, I want to know how much aluminum is going to be made, and I was given my electrons, so I should have my aluminum over my electrons. So there we go. I'm going to divide by 3 to get my aluminum because there's 3 electrons for every 1 aluminum produced. Now, okay, balanced equation, moles of given, mole ratio. Last step is to find the amount required. The question asks for the mass of aluminum, so we want mass. So we know if we want to get from moles to mass, we got to use molar mass. And right now we have moles and we want mass. So the moles need to go on top. The mass needs to go on top, the moles needs to go on the bottom. We want those moles to cancel out and we want the mass. So I'm going to times it by the molar mass of aluminum. Now if I look, my units are canceling out. My hours are gone, my seconds are gone, my coulombs are gone, my moles of electrons are gone, and my moles of aluminum are gone. So what am I left with? I'm left with my mass of aluminum, which is what I wanted. So I punch all that in my calculator, and I end up with a nice big number, 83,000 grams of aluminum produced. And that's kind of what we're looking for in an industrial process. We don't want to do like what that calculation in class where we made 11 grams. We need to make a whole bunch of aluminum in a relatively short period of time, and you can do that with a really high current, like this 50,000 amps. So I look at my options, and it looks like B would be the answer. 8.39 times 10 to the 4 grams would be produced by 50,000 amps in 5 hours.